Our upcoming DevOps enthusiast works as an HCL software transformation architect with more than 20 years of practical field experience in development roles, driving thought leadership, strategic initiatives, and tangible solutions around DevOps and continuous delivery. Focusing primarily on value stream management, deployment automation, and continuous testing, our speaker has practical knowledge of the HCL software DevOps solution set, having assisted, mentored, and enabled client teams to help solve their IT challenges. Ladies and gentlemen, that's Al Wagner for you. Now, he's not alone. Al will be joined by his co-speaker, Colin Bell, who is serving as the AppScan CTO within HCL software team. Over the past 18 years, he has specialized his skills in application security and the deployment of the AppScan portfolio to customers worldwide. Together, this dynamic pair is going to share the golden nuggets of insights on how the right tools can make it easier to govern, measure, and manage your SDLC. Ladies and gentlemen, let's now happily welcome onto our screens the wonderful pair, Al Wagner and Colin Bell. Al and Colin, over to you.
Hi, and welcome to this demo featuring HCL Software's DevOps solutions and how they can support organizations in their DevOps and value stream management journeys to increase business agility as part of a securely managed DevOps pipeline. It should be no surprise that organizations have been on a journey of improvement for some time, adopting agile development practices and lean process to improve process efficiency while eliminating waste, automating the repeatable tasks making up the delivery pipeline, and embracing DevOps practices to accelerate delivery of software to the end user. And now many organizations are embracing value stream management with the objective of improving flow across the software delivery pipeline, from inception to implementation and beyond, and measuring the value of software releases to the business. HCL Accelerate provides value to organizations embracing value stream management, delivering features and functions spanning 4 main capability areas. For Agile teams, the value stream view presents details showing all the work being done by the product or project teams responsible for its delivery, including metrics and bottleneck detection functionality to help improve flow. The pipeline view helps DevOps teams know which version of a deployable artifact currently resides in each delivery pipeline environment. The release management capability allows teams to schedule and orchestrate the release of software change with the right level of governance to reduce risk to the business. And transformation leaders will appreciate Accelerate's insight functionality, presenting data, both past and present, in a number of dashboards and charts to help teams identify trends, compare team performance and scale best practices across the organization, or leverage data to make better decisions. Data which is synchronized with Accelerate from many tools making up an organization's delivery pipeline. Whether the source of data be from a continuous integration, continuous delivery, continuous testing or security, or continuous availability solution, HCL Accelerate can make the connection to the tools repository, understand the data, and import that data into Accelerate using one of the many available plugins. So let's look at some of the HCL software products in the HCL Software DevOps portfolio and show how they can help solve real-world challenges. Starting off in HCL Accelerate Settings Integration View, we can see active connections to a couple of Jira projects, GitHub repositories, and Jenkins and HCL instances to automate deployments. And while we are not demoing all possible integrations, know that HCL Accelerate offers integrations to many more tools. The Plugins view shows all of the integrations provided in Accelerate out of the box. And if there's an integration you would like to see, know that the development team is regularly adding new integrations. With the desired integrations in place, now let's take a look at the flexibility Accelerate offers, allowing teams to define how the data can be displayed using a number of different value stream designs. From HCL Accelerate's homepage, the user can see all of the recently viewed value streams and releases. Clicking on the Emerald Portfolio All Work Items value stream, this aggregate value stream has been defined to combine data from all product teams, presenting a higher level view which may be appealing for the business stakeholder or leader who is interested in the three basic phases in software delivery: to do, doing, and done. Reviewing the legend, the viewer can quickly identify, even in this roll-up value stream, which stage is running slow, in this case planning, and which stage is running fast, in progress. And the legend also describes the shape of the dot by work item type, as well as whether that work item is running late or exceeding the average time the work spends in a particular stage. Another Accelerate feature is the ability to filter data using plain text queries, or HCL Accelerate's DevOps query language. In this example, the viewer is quickly able to filter and display work items by the Jira project names. The Value Streams view is another way to display a listing of all value streams configured. The difference is that this particular view allows organizations to display a number of the KPIs for each value stream, basically providing a report card showing key data metrics and trends to measure the current state as well as to help identify potential opportunities for improvement. One of the more interesting metrics presented in this view is the bottleneck detection metric. Accelerate uses AI technology applying algorithms against the data to proactively identify which stage in the value stream needs attention. And there are three bottleneck detection algorithms available: dominant stage bottleneck, batching bottleneck, and inflow-outflow asymmetry bottleneck. In this example, Accelerate has detected a dominant stage bottleneck in the aggregate all work items value stream and a flow imbalance or inflow-outflow asymmetry bottleneck on the Storefront product team value stream. Dominant stage bottlenecks are identified when the time work items spend in one stage exceeds the total time of all other stages. Batching bottlenecks are identified when many work items move between stages together in batches, and inflow-outflow asymmetry bottlenecks are identified when work enters a particular stage more frequently and faster than work leaving that stage, a flow imbalance. From the value streams view, let's check out some of the other value stream designs. The Emerald Portfolio All Active Work by Product Team value stream is another aggregate value stream view combining data from the two product team value streams. Thanks to the new multi-branching capability provided in Accelerate version 2.4, teams can now programmatically design the value stream to isolate work into branch stages. Where in the first example, the in-progress phase was showing the development stage as being fast, in this visualization where the progress is separated by team, one can see that the inventory product team is able to process work faster than the storefront product team. This view also shows that the storefront product team may be having some challenges as the work in progress threshold or WIP limit has been exceeded. Next in the list, and again thanks to the multi-branching capability, is a value stream which has been designed to show epics by team and the status of that epic. This value stream design may be most appealing for the product owner or business leader. Using Accelerate's View Value Stream Data by feature, viewers can easily change the display showing epics by release, by priority, or by type. Now let's look at a value stream design which may be most appealing for the App Dev Manager who oversees the activity of multiple product teams. With this value stream design, the App Dev Manager can get a holistic view across all product teams, identifying areas needing improvement, and aid in remediating any issues the teams may be dealing with. From this example, the App Dev Manager can easily see that the QA stage in the inventory product team value stream is showing that work spends 28 days in this stage on average, and as a result, work is backing up in the dev environment and new builds are not being deployed quickly so that they can be tested. The App Dev Manager also knows that the team has been asking for support to implement automated tests and security scans and have been running experiments to find ways of speeding up QA. Being able to see the upstream impact of a slow QA stage, the App Dev Manager immediately shares their approval to move forward with the automation. Switching attention to the storefront value stream, the App Dev Manager comes to realize that this team's challenges are different. Armed with the knowledge that a high priority defect has recently been identified in production for the Emerald storefront, the App Dev Manager sees how this unplanned work is negatively impacting flow. And with the submission of this defect, the work in progress limit has been exceeded. And, due to the high visibility of this escalated defect, it is all hands on deck to fix. However, this unplanned work is causing other planned work to back up. Using data, the App Dev Manager has a better understanding of the problem, the impact of unplanned work, and how to help the Storefront team to get things moving again. So let's unblock the Storefront product team first. We know that a defect has been reported. Working in Accelerate, we will investigate the defect work item, understand the status of the situation, and quickly move the fix through the delivery pipeline, deploying the updated software into the production environment. We start by checking the application in production to better understand the problem which is causing confusion with new customers looking to register with the Emerald application and complete their purchases. Returning to HCL Accelerate and opening the Storefront product team value stream, the team lead uses filtering capabilities to locate the defect to be worked on. Clicking on the work item dot, the team lead can get additional information to investigate further. In this case, the team lead is most interested in the work item ID and the name of the work item owner. Performing a plain text search on the work item ID, the team lead can also see that there is a pull request assigned requesting review of the code changes to remediate the production issue. Switching to the Swimlanes view and viewing by owner, the team lead sees that she is actually the holdup and needs to address the pull request to get things moving. In many organizations, the work item and pull request would be stored in separate repositories. As the Jira repo and the GitHub repo have been integrated with HCL Accelerate, the two related work activities can be linked together, showing these potential holdups. The team lead reviews the committed code change and closes the pull request. Through the synchronization with GitHub, the closed pull request, represented as a square in Accelerate, disappears from the value stream and the accepted code change is merged and built, creating a new deployable artifact. Switching to the pipeline view for the Storefront value stream, the team lead can see that version 9.16 is now available for deployment. The pipeline view also shows which version of the Emerald application is currently deployed in each of the environments making up the delivery pipeline. Time to deploy the latest software and check to make sure it meets acceptable levels of quality in the dev, test, and demo environments en route to production. But before we get ahead of ourselves, the first step is to deploy to the dev environment. Working in HCL Launch, HCL Software's deployment automation solution, the release engineer checks that the latest version for deployment is available. Selecting version 9.16 of the Emerald application, they initiate the deployment process by specifying the deployment process to be executed, confirming the payload which will be deployed, confirming that all property value requirements within the deployment process have been satisfied, identifying if they want to run the deployment immediately or schedule for a later time, and in this case, the deployment is submitted for immediate execution. Upon submission of the deployment process, the release engineer is presented with the deployment execution log where they can monitor the deployment in flight. Expanding the execution log exposes details of the various steps performed during the deployment, and displaying a steps output log presents details of what occurred during execution of the step. In this example, we can see that the step successfully rolled out and started a new version of the Emerald application container. And with a quick check of the Emerald application, we can see that the update was successful. Back in HCL Accelerate, the team lead sees the pipeline inventory update and that Emerald version 9.16 is now in the dev environment. As the various checks are performed and if quality is at an acceptable level, the next step is to move version 9.16 through the other environments towards production. Returning to the Storefront team's value stream view, the team lead can see the defect work item advance through the various value stream stages with each deployment, from work to test, test to demo, and finally demo to prod. Another feature of HCL Accelerate is the audit log or digital chain of custody. As a work item moves through the various stages and is subjected to various levels of testing, all this information is persisted in the log. Clicking on the work item exposes this audit history where the user can see linkage to the pull request, how long the work item spent in each stage, test execution result, which build the work item software change was first included in, and having quick access to this level of information can go a long way in responding to auditors. Now that the defect has been fixed and deployed in production, the team can get back to their other planned work. At this time, let's dive a little deeper into how the value stream is defined and other features Accelerate offers the end user. Clicking on the wrench icon allows authorized users to download the value stream JSON file for modifications or to upload a new JSON file. For the purposes of this demo, we will simply open the JSON file directly in a text editor. As no organization's workflow is exactly the same, the flexibility provided by Accelerate enables organizations to design the value stream aligned to their exact needs. A starting point in designing the value stream is to identify the phases, and within each phase are a number of stages. Work items displayed in each stage depend on the stage query. In this case, all the dots displayed in the submitted stage of the planning phase are work items which have a status of submitted. Looking at the development phase, we can see that 2 stages, work and review, have been declared along with the queries to display the work items in those stages. And new in Accelerate 2.4 is the ability to declare stage targets, which allows value stream branching in alignment with many planning tool state models. Another configurable parameter is the work in progress or WIP limit, which can be set for each value stream stage. In this demo example, the WIP limit is set to 4. However, you may recall that there are 7 work items currently in this state, and which has triggered an alert. Next, let's look at the final 2 phases and their stage definitions. How lead time and cycle time is calculated is also configured in the value stream. In this case, lead time will be calculated starting from time work enters the backlog stage until it is in production, where cycle time is calculated from the time work is started until it is in the hands of the end user. Of course, organizations can set start and stop stages for each of these calculations based on the stage names in their value streams. Now let's look at the integrations and how the value stream is connected to external repositories. In this example, the Storefront value stream is connected to Jira and GitHub, as well as the bottleneck detection plugin installation. And finally, the link rules. Link rules define how the integrated tools are related to one another. In our demo, a link rule has been implemented to create a relationship between the issue ID of the work item and the name of the pull request. If you remember back to remediation of the defect and reviewing the audit log of the work item in production, the audit trail showed a relationship between the defect work item and the pull request. This relationship existed because of this link rule. Moving out of the workflow JSON file explanation and returning to the value stream view, across the top is the metrics bar. Teams can select up to 6 metrics to be displayed from a long list of readily available metrics, or create their own, adding the metric specification to Accelerate via an API command. While we briefly showed the view value stream data by options and filtering capabilities earlier on, notice how applying these filters can change the work item displayed in the value stream and adjust calculations around work item counts at the various stages. In this example, we first viewed the work item by type and then filtered out all the epics from the value stream. This filtering, in turn, changed the count of the work items in the work stage, as well as the work in progress limit count. The Swimlane view presents another way to view the value stream data. The owner view displays the work currently assigned to all members of the product or project team. The ability to collapse and expand a value stream phase allows one to focus on a specific area of the value stream. In this example, the team lead can easily see work distribution across the team and assign work appropriately. As an alternative, viewing work by owner can also help identify when a resource may become overloaded and work is taking longer than expected to complete. The priority view presents the importance of all work item and displays what stage they are within the value stream. Viewing work items by type helps visualize distribution and answer if there is the right level of new features versus defects currently in the pipeline. Views like Release and Sprint allows leadership to quickly get a status of all work items by delivery pipeline phase and stage. And the Epics view provides product owners as well as leadership with the ability to quickly see all work status associated by Epic to know if things are progressing as anticipated and required. Now let's look at how the HCL Software DevOps solution can help the inventory team eliminate delays in the QA stage and incorporate automated testing and security scans to speed up and optimize flow. If you recall, the AppDev Manager, in viewing the all teams aggregate value stream, noticed the upstream impact of testing delays in the QA stage. As a result, they provided approval and released funding to implement improvements in how testing and security scans are performed. The team has been mobilized to implement the improvements and fast-track the resolution. So let's begin our journey in Accelerate, reviewing the Emerald product team inventory value stream. Accelerate has clearly identified a flow imbalance bottleneck in the QA stage, as work is not exiting this stage quickly enough when compared to new work waiting to come in. We can also see that work is waiting in the dev and build stages as we wait for QA work to finish up. Moving to the pipeline view, the team lead can also see that the version of the inventory reporting application currently in the QA stage is not providing a sufficient level of quality or security, yet version 11.02 seems to meet quality criteria in the dev environment. Quality levels displayed as green or red can be automatically determined by smart gates and the analysis of execution results shared back to Accelerate. By implementing smart gates, teams can make sure that only application versions which present an acceptable level of quality and security can be promoted to the next environment. Gate conditions are set by defining manual or automated rules. In this example, we will add rules to automatically check application functionality and application security. The first rule to be implemented will check the results of static scans executed against the build version, and the rule condition will only allow build versions with 0 blockers to be deployed. Next, let's add a gate rule to ensure that a satisfactory level of functionality will be released by making sure that only builds where all functional tests have passed will be deployed into production. Smart gates allow teams to automate governance, checking quality levels and reducing risk to the business, minimizing the number of issues which may escape into production and negatively impact clients. With the smart gate rules implemented, it is time to begin the journey of promoting version 11.02 of the inventory reporting application to production status. Now, as mentioned earlier, the inventory team has been experimenting with test automation and created a number of automated integration, functional, and performance tests to be run as part of an automated deployment process. The security team also wants to save time by enabling interactive scanning monitors while testing is underway and include static and dynamic scans of the application after it is deployed. So, working in launch, the team enhances the existing deployment process to incorporate these automated test assets, subjecting the application to different types of testing depending on the environment the build version is being deployed into. We can see that the team has already been busy updating the deployment process and is finishing up by adding a step to execute performance tests. This step is wired into the deployment process after the step executing functional tests, and following the completion of the performance test execution, the deployment process will execute static and dynamic scans in parallel. The result is an automated deployment process where updates to the report generator and report presentation application components will be tested as they are deployed. This means that after the deployment, there is a check to see which environment the components were deployed to, and in the case of a QA environment deployment, the process activates IAST monitors, executes functional tests, executes performance tests, runs static and dynamic security scans, and uploads the testing results to Accelerate. So let's kick off the deployment and see how test automation and security scanning fits into deployment automation. Looking at the HCL launch environment view, we can see that 11.02 is currently deployed in dev, and we could request a deployment to QA. But different from last time, let's kick off the deployment from the HCL Accelerate pipeline view. From the QA environment in the HCL Accelerate pipeline view, we select the deploy option, followed by specifying the version of the application, which offers an acceptable level of quality to be deployed. This is followed by clicking deploy. What happens behind the scenes is that, through the integration with HCL Launch, Accelerate has sent a deployment process request to launch for the QA environment. Returning to launch and requesting to view the deployment process in flight, the team can see the deployment process as steps are executed. In this example, the application components have been successfully deployed. Next, the deployment environment was checked, and because it was QA, the process knows to activate the security monitors. Next, the functional tests are run, followed by execution of the performance tests. When the performance tests finish, the security scans are run, and the quality test results are uploaded to Accelerate. And as a final step, the security monitors are disabled. A successful completion of the deployment process signifies that all tests and scan have run successfully, and the integration between Launch and Accelerate updates the pipeline view to show version 11.02 deployed in QA, presenting an acceptable level of quality. Next, let's add version 11.02 of the inventory reporting application to an already scheduled weekly release of the inventory applications to production. From the prod environment dropdown, and after selecting the join release option, the specific release to be joined to is selected, and again the specific application and application version is specified. Moving to HCL Accelerate's release view, the team can see that there are currently 2 scheduled releases on the calendar, and the week 26 release is scheduled for execution just ahead of a maintenance window. Accelerate also allows scheduled releases to be kicked off manually. Clicking on the scheduled release calendar entry, the release engineer can open a copy of the approved release template containing the necessary steps to ensure compliance and reduce risk to the business. While this demo release is rather simplistic, know that Accelerate offers integrations to ServiceNow and other solutions where steps to ensure compliance can be included in the release plan. The first step in our approved release process is to notify teams that a release is starting. This is followed by an approval step, and with the pre-deployment steps taken care of, automation takes over where some updates are made to the production environment, followed by deployment of the new application version. As deployment completes, the release plan waits for the final step where the release engineer is to confirm that the team has been notified of the release status. With the release complete, we can return to the inventory team's pipeline view and confirm that version 11.02 is now in production. Overall, the Emerald business, and particularly the inventory product team, is already realizing a significant improvement in flow and a healthy return on investment as integrating test automation and security scans in the deployment process is accelerating feedback on software quality, as well as decreasing the time work spends in the QA stage. Now let's explore the insight capabilities where teams can define dashboards and add a number of charts to display data in a manner which makes sense for their organization. While a number of dashboards have already been set up for the demo, organizations can create as many or as few dashboards with charts to meet their needs. In this example, the dashboards have been set up by specific categories: overall delivery performance, software quality measurements, and enterprise application security. Starting off in the delivery performance dashboard, the team would like to include deployment data, and from the Add Charts view, they can select the deployment counts chart to be added to the dashboard. However, teams may choose to add any of the charts presented in the list or add custom charts to the list. With the new deployment counts chart added to the dashboard, the team decides to view this data by week instead of by day, making it easier to understand the data being displayed. Teams may also want to leverage HCL Accelerate's dashboard filtering capabilities to review dashboard data by application, by value stream, or by team to gain insights and compare teams to see if one team is getting better results or seeing a higher level of delivery success. Filtering also allows leadership to look at data in different ways, having the ability to identify and scale one team's best practices across the organization can improve delivery capabilities across all teams. Now let's look at the quality metrics dashboard. On this dashboard, we are showing numerous charts related to software quality and presenting the charts in different ways. For example, perhaps the team wants to make the prod incidents chart larger and more predominant. They can do that. Perhaps the team wants test execution results displayed in one row in the dashboard. They can do that. Perhaps the team only wants to display a particular chart field and modify the presentation style of the chart. They can do that as well. On the enterprise security dashboard, the team realizes that as they have been executing security tests for only the last 30 days, Setting the time frame to the last 30 days instead of 90 removes white space and expands the view, allowing teams to focus on data they do have. And clicking on the magnifying glass icon allows teams to drill into the chart data details. In this example, and having drilled into the static analysis chart, the team can see the latest scan results for the Emerald application, and more specifically that build 914 of the Emerald application currently has 1 high, 3 medium, 4 low, and 4 info vulnerabilities, along with a link to the scan details if additional information is required. The last part of the Insights capabilities is the report functionality. The Accelerate team is working hard to add new reporting options, but for now, let's look at the state of sprint report. Clicking Run Report, the user selects the value stream they would like to report on. Once the selection is confirmed, Accelerate begins the process of compiling the data and assembling the report, which can be shared with others or viewed by clicking the results link. What the State of Sprint report highlights is that in sprints 1011 and 1012, there are some stories without points. And in future sprints scheduled for the Storefront team, none of the stories have been pointed yet. Scrolling down to the Plan versus Done section, the viewer can see that the team has delivered on all planned work in sprints 1001 and 1002. There has been a large increase in points planned for the active sprint 1011, and the team has yet to complete any of that work. This is potentially due to the increased level of complexity and perhaps something requiring further investigation. And after moving to the active sprint 1011 sprint details, the viewer can see a total of 5 work items are in progress with a total of 21 points. One of the stories has not been pointed, so the development effort is even higher, and there is a total of 3 people currently assigned work in this sprint. Looking across the value stream stages, there are currently 3 work items in progress, 2 stories and 1 bug, 1 story being tested, and 1 story is being demoed to stakeholders. And clicking the View Issues in the sprint presents details on each work item as well as links to the work item in the Jira repository. So in this demo, let's reflect on what was shown. Accelerate integrates with a large number of tools to display data from the various repositories in a single pane of glass. Accelerate provides a number of KPIs allowing organizations to begin measuring improvement on day 1. Accelerate delivers AI capabilities and alerts to help teams identify bottlenecks and focus on remediating challenges to improve flow. Accelerate allows organizations to manage application inventory across all environments and orchestrate releases with the right level of governance, reducing risk to the business. And finally, Accelerate provides insight and presents data in meaningful ways, helping teams improve flow while making better decisions as they work to deliver value to the business. Thanks for watching.
So having looked at DevOps, let's consider secure DevOps, and even further to that, let's consider continuous security. Continuous security is a model which we break into 3 main phases: construction phase, an intensify phase, and an insurance phase. And really what we're trying to get across here is the concept of being able to work with the application. So the minute that we start writing or designing the application, we're embedding security within that. And as we move through the software development lifecycle, we're also being very much aware that we need to look at different aspects as we move through that cycle. So what happens in the build phase? What happens when we're doing our functional testing? What happens where we're doing our security testing? All play a part in making decisions around how secure the application is. And by looking at the measurements that are coming from the system, we can make strong decisions around how secure the application is and how we're going to take that forward. So the starting point for continuous security could be anywhere in the SDLC. And in this model, we have design and plan, code, automate, test, and run. And obviously that can split out into a much wider range of activities. But ultimately, the starting point for many security programs is from governance. And that could lead from some level of compliance or some level of security requirements that are required for the application in order for it to be taken forward. And those requirements would lead into how we're going to design the application in the first instance. In the coding phase, I'm going to look at two aspects here. I'm going to look at what happens as we write the code and look at AppScan code sweep, and then also look at how we can actually do scanning and look at results from within the IDE itself. These are very important early phases for the application security process. For a developer experienced with security, we can provide a means to see vulnerabilities in the code as it's being written using AppScan Code Sweep. Code Sweep is a community-based plugin that works directly into the IDE. Here I have this plugin working, and I'm going to modify my code to add some credentials for the login sequence. As soon as I save this, AppScan presents two new security issues. I can see from this that the issue relates to having hard-coded credentials in the code. I can see details of the issue, and I can also see mitigation strategies for how I might fix this. If I don't want to see a specific issue, I can mark them as noise and move on. I can also disable the rule fully if I don't want to see the issue again in the future. This level of testing only applies for the developer working with the code, and as such is only really for their benefit. Another way a developer can interact with the security issues is by working with the results of the scan directly in their IDE. In this case, I'm working on a Java application, which was scanned during the automation process. I've loaded the results from the portal directly into the IDE, and this allows me to triage them. These are the results that are non-compliant with my security policy. So I can see some open source issues here. There's some SQL injection problems. One really good feature of AppScan is that it presents these issues in what we call fix groups. So in this case, a SQL injection issue breaks into 5 distinct issues. If I click on these, I get the advisory details of the issue. I can drill into these and get more specifics, and I can see, for example, the data flow from the trace details of the data. And this is shown from source to sink, or the entry point to the exit point. I can see the lines of code and also where the issue occurs. AppScan also presents suggestions of where you might want to place that fix for maximum effect. Once it is corrected, I can resubmit a new scan directly from the IDE, or I can mark the status of the issue as being in progress, which is also reflected back in the AppScan portal. In this way, I can work seamlessly within the IDE and not have to move into another toolset. For continuous security, we need to also have a level of build automation for the application. But before we configure this, it's important to determine what we are going to be testing and what decisions will allow us to pass the application. Some level of governance may be in place that will influence the types of security policy we need to apply. This policy might be, for example, to identify any issues where there are significant input sanitization issues, such as SQL injection or cross-site scripting. By building this policy, I can ensure as I automate the build process. I can use the policy to determine if I will pass or fail the build. As our first automation step, let's look at static analysis, or the SAST automation. So let's look at static automation process using Azure DevOps. I'm firstly going to navigate to my project or pipeline. In this instance, I'm showing the use of the AppScan plugin for Azure. This plugin allows developers and build engineers to set up and configure the security automation process. Firstly, I need to provide some credentials to access the application, then choose the application that I want to scan. In this case, I'm going to choose to scan the new customer API. I'm also going to select static analysis as the scan type. There are some additional options too that I might want to configure. I can determine the speed of the scan. I'm going to, in this case, choose a deep scan for a more complete coverage. And finally, I can choose whether to fail the build or not based upon any issues that arise that may conflict with the policy I have in place. So I'll queue the build and I'll let it run. Here I have some previous jobs and one of the scans that failed due to non-compliant issues. I can look at the details in the logs and the extensions to show that I have 3 high issues. If I log into AppScan on cloud, in the portal, I can see more details of these results. I can look at the issues and determine what has caused the build to fail. And by applying a SAS filter, I can see the non-compliant issues that match what was seen on the Azure console. I can now triage these within AppScan on cloud, and I've also gathered my metrics to a central point to make decisions on the best actions to take. Now let's consider adding additional levels of automation, in this case dynamic analysis or DAST. I could run this from a number of different ways. For DAST automation, I might, for example, automate directly from a functional testing step, where this is already automated, such as something that might come from HCL OneTest or from Selenium. We can also do a dynamic automation from the CI/CD pipeline with AppScan. In this demo, I'm also going to combine interactive application security testing, or IAST, to enhance the information provided and increase the overall accuracy of the results. I've already created an application for myself, and I have my IAST agent installed on the application server. So working in Jenkins in this case, I'm going to configure the build to include the dynamic analysis. Using the AppScan plugin for Jenkins, I'm going to configure a step for AppScan. I will provide the application name, the target URL, login credentials, and also the details of the level of intensity of scanning I want to occur. It is possible to have some pre-recorded traffic flow also imported as part of a scan file, and this will allow me to have a more targeted scan. Perhaps the steps of a new functionality in the application, for example. I can also add in some fail build conditions, perhaps the number of high issues, or the failure to meet an application security policy that I have in place. So now that I have this, I can save this, and then in Jenkins trigger the build. While that is running, I'll look at AppScan on cloud, and I'll examine the IAST agent. As soon as the scan starts running transactions on the server as part of the DAST scan, the IAST agent is also identifying issues. Here you'll notice it has already identified some SQL injection issues. I can also look within the DAST job and see the issues are also being reported. So I have the ability to combine both of these to give a more exact understanding of what's going on in the application. As the application progresses through the SDLC, it's possible to include levels of security testing as the application moves into test. Our IAST agent, which I showed previously, can also be configured while functional testing is happening. It is also possible to have a level of runtime application monitoring through RASP solutions as the application moves into production. The AppScan IAST capability is very versatile and is easy to set up. Let's take a closer look at how this can assist in the testing phase. To demonstrate how easy it is to configure, I'll first install the agent on my local machine. I will first check that my local application server is running. So I will, in this example, launch my Tomcat server. To create a new scan, I will log into AppScan on Cloud or ASOC, start a new scan, select IAST, and download the agent. So here I'm going to deploy the WAR file of the agent into the Apache Tomcat server, and the rest will happen automatically. Once this occurs, the WAR file is extracted and the agent is running on the server. Now, any application that is running on the server will be monitored. I will, in this case, launch a demo application, Tora Mutual, and I'll start interacting with it, logging on and selecting some functions. I'm not doing anything malicious here, just interacting as normal. When I return to ASOC, I can see that the agent is running And if I wait a few seconds, I can also see that issues are being identified. In essence, this will keep reporting any issues identified while the agent is running. As such, this is ideally suited to a functional testing scenario, where a testing team might be running multiple test cases. The agent can monitor this from a security perspective. As the application reaches pre-production phase, it's very common to have levels of pen testing and security audit. If we are doing continuous security, then the security team would have a significant input into the overall application security and should have visibility into everything that occurs to the application to this point. Within the security audit function, we can expect more focused and detailed levels of testing. The team may use tools like AppScan Standard or AppScan Source to drill to deep levels within the application. An example of a deeper security test might be to look at the testing of web services or APIs directly. In this example, I'll use AppScan Standard to demonstrate how this might be achieved. AppScan Standard has a direct integration with Postman and SoapUI to provide a level of testing. Here I will set up a scan and select Postman to test some of the APIs. This configures Postman to work with AppScan's proxy to configure the traffic as it's being used. So as I interact with Postman, the traffic is captured in AppScan and as part of its explore phase. AppScan will then be able to scan based upon the entities that were identified. Another way of testing APIs is to look at configuring a scan through Swagger. By using AppScan's Web Services wizard, it's possible to point this at a Swagger instance. It can then identify the sequence that might be tested. These sequences can be combined into multi-step processes to reflect how they might work within the application, and thus allow these services to be tested and scanned in a functional flow. Although AppScan provides some level of parameter values, these can also be modified to be real values to ensure the right level of coverage. In essence, this allows a power user to have much more say over how they're going to scan things like web services and APIs. And this is a really good example of what someone that might be doing a pen test or a deeper security audit of an application might be trying to achieve. The audit team can also take information from the application in production, perhaps looking at intrusion detection logs. All of this data should feed into our console and help make informed decisions on the security posture of the application. In a continuous security process, audit should be determining if the application is meeting the levels of the governance that is set out. As these steps combine, I can use the main AppScan on Cloud portal to provide an overarching look at the security results, the scan results, and the overall application posture from a security perspective. I can, for example, use policies to define my own criteria for the compliance and also have this work against the applications at all levels. For example, we can look at this from a SAST, DAST, or IAST perspective. This can greatly allow for the prioritization of findings and issue management through the SDLC. It's also possible to build security reports based upon the policy from an industry compliance perspective from this point of view, such as a PCI or OWASP report. This can be done at a scan level or an overall application level, thus providing easy means to make decisions on the application. As it was also shown earlier, it's also possible to extract or integrate the security data to a higher workflow analysis level, as demonstrated earlier with HCL Accelerate. At this level, the application security data can be viewed at an enterprise-wide level, thus allowing the decisions to focus on where improvements may be needed from an education or security awareness point of view. The 3 points of govern, audit, and measure thus ensure the applications are in a continuous level of improvement. The data available can help to make strategic decisions to the dev teams around secure coding techniques, security awareness to developers, perhaps even an increased program around building security champions within the dev teams, or improving the overall threat modeling. In this way, continuous security works to all aspects of the SDLC and ensures that we move beyond just DevSecOps. Thank you for joining us for this presentation on DevOps and continuous security. I hope you found this informative. Please reach out to us if you want more details or have any questions related to the presentation in general. Thank you very much.